So, if you're joining us for this deep dive, you are probably trying to make sense of, well, just the absolute whirlwind of news and hype surrounding artificial intelligence right now.
Oh, yeah. It is everywhere.
Right. And our mission today is entirely focused on you, the listener, who just wants to cut through all that noise.
Exactly.
Because we've got this really fascinating stack of source documents today, and they detail exactly how, when, and, most importantly, why AI fails.
Which is crucial if we want to actually understand these systems.
Totally. To understand how they operate in the real world, we have to decode this central mystery, right? Like, why can AI sound so incredibly, astonishingly smart while simultaneously being just dangerously wrong? Okay, let's unpack this. So we have to start with this wild story from February 2023.
Oh, the Stephen Schwartz case.
Yes, the New York lawyer. So he submits this highly researched legal brief to a federal judge. He's representing a client in a personal injury lawsuit against an airline, so, high stakes.
Right, very high stakes.
And this brief is just packed with case law. I mean, he cited over a dozen previous court decisions perfectly supporting his argument. Dates, jurisdictions, precedents. It looked incredibly rigorous.
It looked flawless on paper.
But there was just one massive problem when the judge actually sat down to review the brief. None of those cases existed.
Yeah, they were complete phantoms. I mean, the judge obviously asked Schwartz to provide the actual copies of these decisions, and Schwartz comes up empty.
Just totally empty-handed.
Because he couldn't provide them.
Oh.
He'd used ChatGPT to help research his legal brief, and, well, he didn't verify whether the cases the system so confidently spat out were actually real.
Wow.
The AI had just invented them out of whole cloth. It wrote them in this precise, flawless legal language, complete with highly realistic-sounding docket numbers and, legal citations, and just handed them right over.
And obviously, the judge sanctioned Schwartz and his firm, and this incident became a massive international headline.
Oh, absolutely. And, the sources we are looking at today really require us to pause and question our fundamental assumptions about what the word intelligence even means in the modern era.
Because we do throw that word around very casually.
We really do. But when we look closely at cases like this lawyer with the fake citations, we start to see that what these machines are doing is just fundamentally alien to human thought. Now, the tech industry has a specific term for what happened to that lawyer. They call it a hallucination.
Which, reading through the sources, is perhaps the single most misleading term we could possibly use, right?
Oh, completely.
Like, it makes it sound like the AI is daydreaming or, I don't know, having this profound psychedelic experience or something.
Right. It implies a mind. It implies something dreamy and almost human. But the reality of what the system is actually doing is much more mundane, and frankly, it's much more dangerous. AI language models hallucinate when they generate text that sounds completely plausible, but is entirely factually incorrect.
It's just wrong.
Exactly. And the most vital thing for you to understand here is that they do this regularly, by design. It is a feature of their architecture. It's not a glitch.
Reading through the breakdown of how this works, it immediately made me think of a very specific type of person.
Oh, yeah.
Yeah, dealing with these systems is exactly like having that one incredibly charismatic friend who will confidently give you completely wrong driving directions just to avoid admitting they don't actually know the way.
That is a perfect way to look at it.
Right. But the mechanism of how they lie is what's really fascinating. They aren't just, maliciously trying to send you into a ditch. It's more like they are taking every map they've ever seen in their entire life, mathematically averaging out where a gas station usually is, and then just telling you to turn there with absolute conviction.
Right. They don't know the actual town. They just know the statistical shape of a map. The system prioritizes fluency and confidence over factual accuracy. It literally doesn't know the difference.
So the first question anyone asks when they hear about the lawyer with the fake cases is, why did it lie? Why would a machine designed to process information just make things up instead of just saying, I don't know?
Well, it comes down to a really profound public misunderstanding of the technology.
Yeah.
Most people assume an AI is like a super-powered database, right? Or some highly advanced search engine. They think of it as a truth machine.
Like a giant digital encyclopedia.
Exactly. You ask a question, and it goes into a vast internal filing cabinet, pulls the correct factual document, and reads it to you. That is fundamentally incorrect. They are simply prediction systems.
Wait, so they aren't retrieving information at all? They're predicting it?
Yes. They are trained to predict the most likely next word, or, well, more accurately, the next token, given all the words that came before it in a sequence.
Okay, I see.
And this architecture makes them extraordinarily good at generating coherent, contextually appropriate language. But it does not give them any internal mechanism to distinguish between things that are objectively true in the physical world and things that merely sound like the kind of thing that would be true in a given context.
And the source material gives a really elegant example of this. If you type into one of these models the incomplete sentence, the capital of Australia is, it will correctly output Canberra.
Right. But the mechanism of how it gets to Canberra is the key thing to understand here. It did not look up Australia on a digital map. It did not cross-reference an encyclopedia database.
Right, it's not Googling it.
Exactly. It correctly output Canberra because in the vast, unimaginable terabytes of text it was trained on, the phrase "the capital of Australia is Canberra" just appeared many, many times. The model simply learned the statistical pattern of those words appearing near each other in this multidimensional vector space.
So Canberra is just the mathematically most probable next token to follow that specific sequence of words?
Exactly. And what's fascinating here is the model's complete inability to distinguish between what is an established fact and what merely mimics the structural shape of a fact. Because imagine you ask it something much more obscure than the capital of a major country.
Right.
Imagine you ask it to summarize a specific legal case from 1987 in some minor, highly specialized jurisdiction.
Like Stephen Schwartz did with his airline case.
Exactly like he did. The model has learned millions of patterns about how legal cases are described. It knows the formal formatting intimately. It knows the specific vocabulary. Words like plaintiff, summary judgment, tort.
It knows the vibe of a legal document.
Yes. It knows roughly what such a case might say based on the context of your prompt. So it looks at the prompt, calculates the probabilities, and just generates text that perfectly fits that highly specific pattern.
But whether the specific case it describes actually exists out in the real world is an entirely different question.
Right.
And it's a question the model physically cannot ask itself. It just doesn't have a model for reality testing.
It cannot tell the difference between reality and a very good forgery of reality, because to the model's underlying math, both are just statistically probable strings of words. I mean, the fact that the events never happened is completely irrelevant to the probability calculation.
Wait, hold on. I really need to make sure I'm wrapping my head around this. If I'm asking this system a highly complex, nuanced question, about legal precedent or medical symptoms, it is essentially just playing the world's most advanced high-stakes game of autocomplete.
That is exactly the mechanism. It is literally the world's most sophisticated autocomplete. And when you realize that, the fake legal cases make perfect sense. It was just autocompleting a very convincing, statistically probable legal document.
Okay, well, if it's just predicting the next word based on the patterns of what it has read, I am suddenly very worried about what exactly it has been reading.
Ah, yes. And that means we have to examine the human-generated training data itself. If the AI is simply a mirror reflecting the patterns in its data, it doesn't just reflect grammar and syntax, it reflects everything.
Everything.
Yes. And if we connect this to the bigger picture, this leads us from the realm of harmlessly wrong facts, like a hallucinated court case, into the realm of active systemic bias.
Because human-generated data reflects human biases, human prejudices, and, well, human historical inequities.
Precisely. The sources point to this really landmark piece of research from 2018 by Joy Biolomini at MIT to illustrate how deep this actually goes. She examined commercial facial recognition systems that were being sold by major, highly respected technology companies.
Okay.
Now, we're shifting here from text prediction to image prediction, but the underlying mathematical concept optimizing for patterns in the training data is very similar.
Right, and her research showed that for light-skinned men, these commercial facial recognition systems had an error rate of under 1%. They were highly accurate. But for dark-skinned women, the error rate skyrocketed to up to 35%. I mean, that is a massive failure rate for a deployed commercial product.
It's huge. And to understand why that happens, you really have to look at how the neural network calculates its mathematical weights. These systems had been trained predominantly on images of lighter-skinned faces.
So the data was skewed from the start.
Exactly. If the multidimensional space the AI uses to mathematically define what a face is happens to be populated by, say, 80% light-skinned male faces, the network's weights become highly tuned to those specific features. It tunes to those specific contrast levels, that specific lighting.
Right.
So dark-skinned female faces fall into a very sparse, empty area of that vector space. The model literally lacks the mathematical data points to resolve those patterns accurately.
And the sources detail how this exact same data representation problem has been found across so many different critical AI applications today. We are seeing hiring algorithms, which are trained on historical hiring data, actively filtering out resumes from women and minorities.
Yes, it's a huge issue in HR tech right now.
And the mechanism isn't that the AI has some malicious intent. The historical data it trained on just reflects a literal history of human decisions in the workplace, which, frankly, included a lot of discrimination. So the AI looks at the data, sees that white men were hired most frequently in the past, and just mathematically assumes that is the correct pattern to optimize for in the future.
That's exactly it. And we see the exact same mathematical trap in healthcare. Medical AI systems trained predominantly on health data from European and American hospitals perform significantly worse on patients from other ethnic backgrounds.
Because it hasn't seen the patterns.
Right. The model only knows the distribution of data it has actually seen. The sources also highlight criminal justice algorithms used to predict recidivism, the likelihood of someone reoffending.
Which a judge might look at and just assume is a completely neutral, objective mathematical score.
Exactly. But the real challenge is that these biases are completely invisible within the system's architecture. You cannot open up the code and find a line that says, discriminate against this specific group.
The bias is embedded in the training data itself.
It's baked in. The data is a reflection of the world as it actually was, with all its flaws. So building a fairer AI system requires building a fairer data set, which means meticulously adjusting for the unfairness that exists in the real world. It is a massive social and political challenge, not just a technical one.
It's really not an objective oracle at all. It's more like a funhouse mirror.
Oh, I like that.
Yeah, like we expect a clean mathematical reflection of reality, but instead we hold up our deeply flawed historical data to it, and it just absorbs our societal blind spots, reflects them back at us, and mathematically magnifies them just because it's optimizing for the most common patterns.
A funhouse mirror built out of our own historical data. That's a great way to put it. And it leads us directly to the absolute core flaw of artificial intelligence that their sources identify. This explains why the AI can't just filter out the bad data on its own.
Right, this inability to know that a fake court case isn't real, or that a historical hiring pattern is deeply flawed. It points to a massive void at the center of the technology. The AI doesn't actually comprehend anything it is looking at.
Nothing. It possesses no true understanding. It is extraordinarily good at pattern matching, but it does not conceptualize the world in any way. The source material provides a beautiful contrast to illustrate this. Think about a human child encountering a cat for the very first time.
Okay, a child who has literally never seen a cat before.
Right. Instantly, the human brain goes to work in a conceptual way. The child recognizes that this is a living creature. They intuitively understand that it breathes, that it needs food, that it might scratch them, and that it occupies three-dimensional space. They grasp the concept of the cat.
But an AI image classifier can be trained to identify a cat in a photograph with near-perfect, superhuman accuracy. It can spot a cat in a blurry background in the dark from a weird angle, but it has absolutely zero understanding of what a cat actually is.
Exactly. To the AI, there is no fur, there is no life, there is no hunger. It merely recognizes a specific mathematical arrangement of pixels. It just sees a grid of numbers, and it calculates that this specific grid of numbers highly correlates with the label cat.
And while that distinction might not seem to matter if you're just, sorting photos on your phone, the sources point out that this void of comprehension matters enormously in high-stakes applications, like medical AI.
Yes. Medical AI illustrates the stakes of this comprehension void perfectly. We have developed AI systems that can detect certain cancers in medical images like X-rays or MRIs with an accuracy that matches or sometimes even exceeds the best human radiologists.
And as the text says, that is a genuine, significant achievement. It has the potential to save countless lives.
It is a miraculous technical feat, truly. But because the AI only matches patterns in a grid of numbers and doesn't actually understand biology or medicine, these exact same systems can fail in ways that a human radiologist would literally never fail.
Because they can be completely fooled by spurious correlations, right? Like an image artifact, a smudge on the lens, a weird reflection, a piece of dust. Something that a human doctor would immediately recognize as totally irrelevant to the patient's actual health.
Exactly. The AI might flag that tiny smudge as a massive tumor. Why? Because the AI is optimizing for a loss function based entirely on its training data. If In the training data, a certain hospital scanners always had a smudge on the lens when they scanned severely ill patients, perhaps because they only used that older machine for emergency cases,
Right.
right?
Oh, okay.
The AI simply learns the mathematical rule, smudge equals cancer.
Here's where it gets really interesting. If an AI can beat a top-tier doctor at finding cancer, but then get completely tricked by a piece of dust on the lens, are we as a society just confusing the appearance of intelligence with actual understanding?
Well, this raises an important question, and it is the exact question the sources want us to grapple with today. We naturally assume that if a machine can perform a highly complex task like diagnosing cancer or, passing a bar exam, it must possess human-like reasoning.
Because a human would need reasoning to do that.
Exactly, but the machine doesn't. Now, the sources are very clear here. These bizarre failures are not arguments against using AI in medicine. We shouldn't just throw the technology away. The potential benefits are way too huge.
But they are fierce arguments for using AI carefully.
Yes. They are arguments for mandatory human oversight, for total transparency about the limitations of the system, and for rigorous, time-consuming testing on diverse populations before they are ever deployed in a real hospital.
But the sheer competitive pressure in the tech industry to deploy AI quickly right now, to just be the first to market, is completely overwhelming that caution, which circles us right back to Stephen Schwartz, our lawyer with the fake cases in federal court. The source text calls him an extreme and visible example of what happens when AI systems are trusted without verification. He saw the appearance of intelligence, the formal legal language, and he just assumed actual understanding.
And that same dynamic is playing out in much smaller, less visible ways every single day. It happens whenever someone treats an AI-generated answer as a reliable, hard fact. It happens whenever a company deploys an algorithmic system without adequately checking the distribution of its training data to see if it actually represents the full, diverse range of people whose lives it will affect.
Right. So the failures of AI systems, from the hallucinated legal briefs to the biased hiring software to the medical AI thrown off by a smudge, they really aren't surprises at all.
Not at all. They are the entirely predictable consequences of what these systems fundamentally are. They are, at their core, imperfect pattern-matching machines. They are trained on inherently imperfect human data, and they are being forced to operate in a complex, messy, real world that is always at least slightly different from the historical data they were trained on.
Yeah. If they are used wisely, with appropriate skepticism and human oversight, they are extraordinarily useful tools. But if they're used naively, if we treat them as these infallible oracles of absolute truth, they cause real harm. The source text puts it bluntly. The question is not whether AI will get things wrong. It absolutely will.
The real question is whether we are going to build the systems and the societal practices required to catch those errors before they actually matter. And, well, whether we have the discipline to be honest about the limitations of a technology that has simply become very, very good at sounding like it knows what it's talking about, even when it is entirely lost in its own vector space.
So what does this all mean? It means that as this technology floods into our daily lives, you have to be the human oversight. When you use these tools, you cannot abdicate your judgment. You have to remember the difference between a highly probable string of words and the verifiable truth.
You really have to remember the void of comprehension.
Exactly. To leave you with something to really chew on. Everything we discussed today comes from how AI inherits its flaws by training on imperfect human data. But think about what is happening right now. As AI tools are deployed everywhere, the internet is rapidly filling up with AI-generated text, AI-generated legal summaries, AI-generated images. So what happens to these prediction systems tomorrow when their massive training data is no longer written by flawed humans, but is just a recycled, endless loop of their own confident hallucinations and invisible biases?
Now that is a fascinating problem for the future of the technology.
Something to mull over until next time. Thanks for joining us on this deep dive.